Today we are back on the i8 project, and it's been a few minutes because I don't have a team of Bavarian engineers to support me, and with projects like this, things tend to take a little while, especially when you're just a dude in a shed masquerading as a garage. In this video, we'll give an update of where the project's at, where it's going, and then cover some stuff and things that you may or may not find interesting, like some 3D printed metal solutions, and how we're going to go about mounting things in places they were never designed to go. So this is how we're sitting today. Everything is semi-assembled into the subframe. The street-ported 13B is fully sealed up and ready to go and permanently mated to the DQ500 DSG. We've seemingly stumbled into a black and gold colorway thanks to some gold anodized titanium and some other accents. Now this whole thing is sitting on a very expensive lift cart that I was very unhappy about buying, but this does enable it to get low enough to get under the car and does allow me to move this thing around the garage in the interim. My old lift cart, which is now being occupied by an 8HP50 for another project that you'll be introduced to shortly, goes nowhere near as low as the 3-inch working height of the new cart. So this, in combination with some yet to be designed adapters to my quick jacks, will get everything high enough on the car side and low enough on the motor side to swap this thing out from the bottom. One of the areas of frustration and delay so far has been the intermediate shaft. The factory Audi RS3 unit is too short for my application, so I need to get a custom one made. Ideally, I wanted to find the correct GD&T for the mating splines on these, but I have yet to come up with that, so I will likely need to provide this piece along with the mating parts to whatever shop I'm going to use. I've been in contact with Driveshaft shop, might look at a couple others as well, and essentially they'll take these, replicate them as best they can, which is not ideal, but for a one-off, I guess it's going to be functional enough. And hopefully, if I break something, that any of the replacement parts will fit as well. If any of you have been following along since I built the transmission adapter for my DQ500 7-speed DSG to the rotary, then you would know that I bought a late model MQB series, and my ECU master can only control the early model OBH mechatronics. I finally bit the bullet and bought a Chinese remanufactured set of mechatronics, which was a bit of a challenge in itself, as the first company that I bought it from decided to ship it to Florida and I'm in Connecticut. And then despite the invoice actually having the correct address, they had the gall to say that I provided them with the wrong shipping address. So after a credit card chargeback, I found another Chinese company who successfully managed to deliver the complete mechatronics unit to my door. Everything that I've seen indicates that this is a 100% direct bolt-in swap, and I just haven't performed it yet due to the fact that I don't want to get transmission fluid all over my floor. So one of the areas that we're going to cover are some of the modifications that I had to make to my Borg-Warner 8374 Turbo to integrate it into the rest of the system. Some of you may have noticed that my compressor wheel is a little funny looking, almost like the blades are bent. That is actually because the wheel is from Bullseye Power and is supposed to be their drop-in Batmo wheel upgrade. This was already installed on the turbo that I bought because at the time, other 8374s were on back order, so I bought what I could get, and it remains to be seen whether or not this is actually an upgrade, but we'll find out soon enough. The main thing that we had to do was to integrate an electronic wastegate controller so that we can have full control over the wastegate flapper regardless of any of the intake pressure. Electronic wastegate actuators in general can make a ton of force, and it's very important that you have a very stiff bracket that's not going to flex, because even the smallest amount of wastegate flap actuator movement can have a pretty dramatic effect on your boost control. In my case, the main bracket was 3D printed in stainless steel, and I have a secondary bracket out of aluminum that gets welded to the compressor housing. For any of the 3D printed parts, I'll display the cost for any of these components. Keep in mind that these are pre-tariff, so you will need to add whatever relevant charges depending on where you're located. Decided to chuck the M4 tap into the drill to power tap it, which amazingly did not break off in any of the holes. Now we have a nice triangulated bracket that shouldn't flex under the force of the actuator. Finally, we need a tap for an 1/8 inch NPT plug, and this will likely be getting a water methanol injection nozzle in the future. Next, we need to make a linkage for our electronic wastegate actuator. Here we made a part that connects both to the wastegate actuator flap as well as create a heat shield to keep heat away from the plastic housing in the actuator. For those wondering how I created the hexagon textures on the part, I used the emboss tool. I created a sketch with the hexagons and then used a circular pattern to fill out the rest of the part. One thing to keep in mind when you're using the emboss tool is that none of the sketches can protrude past the body, otherwise it's going to crash and burn. For this part, I decided to try 3D printed titanium for the first time. This will make for a nice, lightweight, low inertia part that's not going to adversely affect the performance of the actuator. To make sure that this tapped nice and straight, we're just going to chuck it in our lathe and then run the tap in by hand. I then used a shoulder bolt and a rod end bolt to round out the rest of the linkage. Hooked up to a benchtop power supply, we can see that we get the full travel of the wastegate actuator arm without any binding and without our bracket moving around. Another quick modification we had to do was to drill out the hole for our compressor wheel speed sensor. It might be tempting to cut that amp connector off and replace it with a Deutsch unit, but there is some internal circuitry in there, so your sensor's not going to work if you go and do that. Next up, we needed some way of putting oil into our 13B once the motor's in the car, and again we turned to 3D printed metal. In this case, an aluminum base that allowed me to use an off-the-shelf 90-degree bend to allow the filler to aesthetically line up with the intake manifold. We did need to thread the top of the filler block for a -12 ORB fitting. I got a bit lazy with fixturing everything up for the port tool, and OSHA has left the chat. With the port correctly sized and all fingers intact, we went through and finished tapping the hole. One thing I omitted originally was a pilot bearing for the adapter for the dual mass flywheel to the 13B. Before final assembly, I machined a pocket for the OEM Volkswagen Audi bearing. With the Rotary, the oil cooler is going to be pretty important because this type of motor uses the oil for cooling just as much as it does the water-based coolant. I decided to use a stacked plate oil to water cooler, much like BMW does, to avoid running oil all the way to the front of the car. There's not really a place for great airflow in the back of the car for a traditional heat exchanger. One of the largest and most available stacked plate coolers I was able to come up with is actually the transmission cooler from a Dodge 2500 pickup truck. For mock-up purposes, I bought the cheapest version on Amazon that I could find, but because it seems that the OEM coolers can fail at a fairly high rate, and there's probably a lot of junk on the aftermarket, if anybody has a line on what the most reliable version of this cooler is, drop a line in the comments so I could pick one of those up. As mentioned earlier, there's not a lot of places to effectively mount things. There's a lot of fairly large objects that have to sit somewhere out in space. For a lot of these, I leveraged our friends over at Send Cut Send to make bent sheet metal brackets to support those components. In order to mount to irregular shapes, I leveraged the use of joggle bends for a lot of these, so you can end up with different planes to attach to different levels of geometry on the same sheet metal part without the use of additional hardware. You can see where I did that here for mounting the ECU mast as well as my auxiliary controller. And using the flat pattern tool in Fusion's sheet metal environment allows an easy export to Send Cut Send. Another pair of large parts hanging out in space are the fuel surge tank as well as the air oil separator. There's an arm that offsets the main mounting bracket from the mounting plate on the subframe. And then I designed a combination bracket that mounts to the factory mounting holes on the surge tank and then utilizes half of the supplied bracket for the air oil separator. The sheet metal portion of the bracket bolts to the subframe where the factory right side motor mount used to reside, but that is no longer used, so I was able to repurpose those holes. Next, we need to turn our attention back to the intake manifold to finish some things off. Upon receipt of the intake manifold gasket, I found there was an opportunity to port match my intake manifold to better match the motor. For fueling, I'm using 6 Injector Dynamics ID 1050s. This is going to be more than enough fuel on gasoline for any of the power that I plan to make with this motor. I did consider E85, but that isn't readily available here in Connecticut, and I'm really not a big fan of ethanol jelly if the car happens to sit for a little while. For me, E85 is going to be more trouble than it's worth. And as usual, we'll pressure test everything because many of the components in this car came out of cars that burnt to the ground, and we do not want to repeat history. At this point, we're getting very close to wiring the car, and I have almost all the components to do so, and therefore we're going to start installing some of the sensors on the engine so we can start running the wires. What we're using for sensors on our fluids is going to be a 145 psi Bosch temperature map sensor. These are used in some OEM applications. I believe this part number goes in an Aston Martin of all things. And these are really handy because, as the name suggests, it has both the pressure sensor as well as the temperature sensor in one unit. Because they are used in OEM applications, you can typically expect some pretty decent reliability, except for the fact that I have seen some complaints about these sensors actually failing. And when they fail, the failure mode is fluid leaking past the internal diaphragm through the pins and into the harness, which the wire is then going to wick the oil, coolant, or fuel up into the harness, and depending on the situation, could even go so far as to getting fluid into your ECU, so that's generally going to be a pretty bad time, all things considered. At that point, I don't think you have any means of actually repairing your harness. You'd probably just have to start over. And what we're going to do here to mitigate that situation is make a small intermediate harness that gets soldered to the pins. Generally, soldering is frowned upon in an automotive application, but the one instance when it is generally acceptable is when it gets potted. So we're going to solder the wires onto here, fill it with a 2-part potting compound, and then that will do two things. It will make sure that our solder joint does not crack, and then furthermore, if the sensor does fail, it will prevent any fluid from reaching the rest of the harness. And before anybody asks, this is a Dymo Rhino 4200 label maker, and I use generic heat shrink label cartridges and then protect them with Raychem clear heat shrink. The connector port on these is kind of deep, and it was a little bit of a pain in the ass to solder to all the pins, especially on the 4th or 5th connection. Maybe next time I will get a longer soldering iron tip to maybe make it a little bit easier, but we were able to make solid connections and then get ready to fill everything up with epoxy.
Actually,
I hate to break to anybody who's already commented, but yes, I do read the data sheets, and I'm well aware that this has a vent to reference atmospheric pressure because these are relative pressure sensors. However, some quick tests after potting reveal that they work exactly as intended, at least at sea level. So ultimately, potting these sensors is going to be the solution that is going to prevent us from ruining our harness and or our ECU in the event of a sensor failure. So for electronic stuff, anytime I have a custom assembly such as this that's potted and the wires go to a non-standard connector, I will typically make a test harness and then have an uninsulated butt connector halfway crimped on one side with the connections labeled. And then this facilitates some very nice easy testing. So if you're at the track or just doing your general assembly and you want to verify that your sensor is working, you can easily access the pins there. Another nice thing is that since these run off 5 volts, if you're ever at the track, you're obviously not going to have a benchtop power supply, but a USB power bank will supply the required 5 volts and has more than enough current to support testing a sensor. So it's a nice, quick and easy power supply if you need it, or even your laptop. But I generally don't like doing that, especially with exposed connections like this, because you could very easily short that out. For our accuracy test, we hooked our sensor up to a benchtop power supply set at 4.95 volts. With our fuel rail pressurized to 95.5 psi, that gives us a reading of 94.99 psi at the sensor, well within the normal range of tolerance. Having possibly created a temperature sensitive air pocket, we decided to try heating up the sensor to 180 degrees, and this gives us a deviation of about 1/4 of a psi. That is plenty accurate enough for oil pressure or fuel pressure. On the topic of wiring, inside this box that UPS so graciously crushed for me, we'll find all of the wiring that I'm going to need for the wiring harness from a pretty cool company called Your Spec Wiring, and you'll see a whole bunch more on them in the full-length video on the wiring harness. But the really cool thing with this is it is all pre-cut to length, pre-terminated on one end, Tefzel, and the cool part is that every single one of these is marked with a custom label as to what I need it to be in my application. So that is a really cool service that can save you a bunch of time and money, and we'll go a lot more into that in the future. So what's next for the project? I'm waiting on the rest of my plumbing hardware so that I can then make mounting brackets, and then those are going to be combination brackets that the wiring harness can run parallel to those hoses wherever possible. Once the wiring harness is complete, we should be in a position to fire this thing in the garage, but now that it's actually mobile, I'll be able to wheel it out into the driveway and then smoke out the entire neighborhood as all the lubricants burn off in the 13B. After that, I've got a number of small parts to design, including a bearing and seal adapter for the intermediate shaft of the transmission. Then I will hopefully be in a spot to swap this thing once it starts getting cold outside. I really don't want to be doing this thing in the middle of the summer, and I'm still enjoying driving the car as it sits. From a timing perspective, I'm hoping to get the car torn apart in late fall after the effective driving season is over and it's not too cold, and I can get this thing into the car before the first snowfall. Once I have it in the car, I'm sure there's going to be a huge number of things that I didn't plan for, but that's half the fun in the problem solving of these projects. With all that said, thanks for watching. I think that's going to wrap it up for this video. If you made it this far, I really appreciate it, and we'll see you next time.